Hi guys, so this one is an example on how to find the natural frequencies and mode shapes. So we have a quite similar setup here. We have M1 equals to 4, M2 equals to 8, and you have K1, K2 and K3, 10, 20 and 30 respectively. So we assume C1, C2 and C3 are zeros. So we would like to find natural frequencies and mode shapes. You can also check out similar problem as example 5.3. So I've given the steps here to solve this problem. So these are the 5 general steps. First step is always when you have a problem, you would want to get the EOM. So you start with the FBD diagram, the free body diagram, and then you need to find the equation of motion. So remember, now we have to do it for M1 and M2. So you're going to have a matrix form, the determinant, rearrange the terms in terms of x1 and x2 and get the determinant and solve for omega 1 square omega 2 square. Remember, it's going to be to the power of 4. So you're going to use your calculator, and your answers from your calculator will be in terms of square. You need to get the square root of those answers and you solve for your mode shapes. X1 equals to 1 because it's a relative amplitudes. You always set x1 equals to 1 and you solve for x2 at each at omega 1 and omega 2 values. So let us take a look how we solve this. So first step is to draw the free body diagram. So you can see here I already have all the forces here. So we have the K1 or 10 goes to the right hand side because we already have assumed direction. X1 and X2 both goes to the right. So that goes to the right. I assume tension in this case. So if tension, the arrows goes outwards. And then for K3, it goes to the right as well. So now I'm just going to draw the action reaction. Okay. So I just have all the action reactions there, opposite and same value. So I want to write the forces on it. So that will be, should be K1 X1 here. So that will be 10 X1. Okay. So what about these forces? So you can see that here, if you take a look at this force, this arrowhead here is to the left, but x1 is to the right. So basically it's negative. So here is negative. And this side is same. To the right is positive. Okay, because x2 is also to the right. Okay, so you may want to write the force here. It should be x2 minus x1. So if I want to write the forces there, so I'm just gonna write K2 is 20. Should be K2 x2 minus x1. So 20 x2 minus x1. Okay, so this one is K3. K3 is 30. So 30 x2. So there's only, it's actually x2 minus 0. Okay, we've done with the free body diagram. Now we want to build up the matrix. So before we build up the matrix, we have to write the equation of motion for both M1 and M2. So I've written the EOM here. So basically the first equation, you can see that you have to write for the first mass, okay, which is this one, M1 x double dot 1 equals to summation of forces. So you can see that the direction to the right is positive, so we use the same designation here. It goes to the right positive, yeah, for both. Okay, so for the first equation, you just write the mass is 4, that's why you have mx double dot 1, m1 x double dot 1. So then you can see that the action reaction forces, one to the left, the 10x1 is to the left, so that's why you get negative. The one to the right, you got positive. So only two forces there, then you rearrange the terms. Same goes for m2 x double dot 2. So you can see that this force goes to the left, so that's why it's negative. This force goes to the left as well, so both are negative. And rearrange the terms, so you do have these two main equation basically for your EOM. Then you have to rearrange that. The next step is you have to rearrange that according to matrix. So we are in the second step. Okay, if this is how you're gonna do for from EOM to matrix. So you have the first equation. So basically in matrix, this first row, if you look at across this, is actually your equation 1. So I have designated that. And if you solve for the second row, is representing actually the second equation. So that's how it goes. So for the first equation, it's 4x double dot 1. So you can see I've put all the vectors here. So the way to read a matrix is basically row times column. So the first element here is actually represents whatever that you times with x double dot 1. Okay, whereas all the column over here, actually you have to times it with x double dot 2. So the way we do it then, you have 4. So basically the coefficient of x double dot 1 is 4. So you do not have any, based on equation 1, you do not have any x double dot 2, so that will become 0. Okay, so the way you do it is 4 times x double dot 1 plus 0 times x double dot 2, so you get 4x double dot 1. Then you have to plus, okay, there's 30 there, so 30, I put 30 here because this one belongs to x1 and negative 20 belongs to x2. So quite similarly, so each of these column over here, it's for x1, okay, basically, whereas column over here is for x2. Okay, if you want to see it that way. Then you keep on. Okay, so I'm using a different color so that you can really clearly see all the first column represent, you have to times with the first element in the vector, and the second column represents what you need to times for the second element in the vector. So then you read across, which represent equation 1 and equation 2. So I hope you can still understand how to write your matrix. So we've done with the second step. Now we want to get the determinant. Okay, how do you go from the matrix to the we want to find the determinant? First of all, you have to assume on the solutions for x1, x2, x double dot 1 and x double dot 2, and you have to substitute into this equation in order to get everything in terms of x1 and x2. So I've done here. After you substitute, you can also see, because you do have this cosine omega t, you can actually factorize this cos omega t and you bring it to the other side of the equation. So basically it will become 0. So 0 divided by anything, because you bring it to the right hand side of the equation, so that's why it will become 0. So if you substitute that, and you can see there is a common vector of x1 and x2 here. So you can write it and collect the terms so that you get everything in terms of x1 and x2. So now it's easy. Then you can actually get your determinant. So how do you find the determinant? Basically A, if you represent it as A, B, C and D, so your determinant is A times D minus B times C. Okay, so from there you can actually calculate the determinant. So basically this is your determinant, and you have to rearrange. So you can see that the power is to the 4 here. So when you actually use your calculator, okay, you can actually put in your calculator the value of A, the value of B, and the value of C. So once you do that, your answers, you're going to get 2 answers. So don't forget, these 2 answers are basically the square of this omega. So you need to take the square root of the omega. Okay, so do the same thing. So then you can get the final answer is 1.8124 and 3.2350. So I guess that's all. We're going to see after this, how do you actually calculate your mode shapes. So you can see these are all the procedures to calculate the natural frequencies. Okay, after that we're going to calculate the mode shapes. Thank you.